All right, recording is rolling. Welcome to Thursday, August 24. So, you guys gonna be back in the lab area most of today, rolling this car down this incline. Here's the picture. Right? Model car here. Right? But you guys saw that Hot Wheels car yesterday, right? Right? It was like rolling down the incline. Right. So, I like to a lot of times kick off new units with labs because it's almost as if you're the scientist back in the day, like working from scratch, almost like cavemen sometimes to say, like, I think you don't know how anything works. Maybe you have some basic measuring tools, right? You're trying to piece everything together. Then by the time you guys come to some conclusion for a lab, then you say, oh, hey, look, the textbook equations exactly match what I discovered myself. So have you guys collect data today? About half of yesterday, I walked you guys through a bunch of considerations. So I'll give you guys a quick recap of that here in a minute. I know you guys have had 6 classes and a whole day since then, right? Some graphs, you'll be able to put together 1 or 2 graphs today, and then we're going to put some graphs together tomorrow as a class also. Right now, for AP, since you guys are AP in front of me, I'm going to have you guys also do a 5-part write-up. I will, one of the papers I've got these written out just like yesterday, so you guys, I'll remind you guys how that works, this 5-part write-up. So today, you guys are mainly doing 2 things. You guys are collecting data in a data table, or the data table that had you guys saw yesterday. And also, while you're at it, doing this 5-part write-up, which you should be able to put on a page, right? Question, measuring tools, maybe like a procedure that's just a handful of steps, usually like 5 to 7 steps, somewhere there, right? Right. The graphs we'll do end of today, tomorrow, and then conclusion, some kind of equation. Right? All right, so before I remind you guys how the slab is working, trigonometry, you guys did a few days ago. You guys were breaking out the protractors and rulers and doing some measuring. And so this trig page, the side with the 5 triangles on the table, I told you guys to do any 3 of those, ignore the other 2. And on the back side are these 10 trig puzzles that are all unique. So I said, go ahead and do all those. Right? This page is due tomorrow. A lot of you guys have already turned those in. You might turn it in today, possibly. If you have any questions on that, you can ask me, ask each other. And another note here, do you guys see those folders hanging from the lab tables back there? See those folders? Right, they've got name tags on them. One of them has your name. So there's the return folders. Now, they don't have anything in them yet because I haven't collected anything engraved and turned them back yet. But I will soon. So while you guys are back in the lab area, it might be a good idea to find where your folder is. They're approximately alphabetical. I've got my own like Griffin system going on, but so by last name it goes like A is over here, and then it like winds around, and then like Z's over there, right? So it kind of winds around. I did have to go with your legal name because I guess that's like a law or something. But if you want me to do some kind of custom name, just turn in that form, and you guys know what I'm talking about. Okay, guys good so far? All right, let's take a look at what's wrong with this lab. Right, so try to give you guys a quick rundown so you have maximum time in class to get the most out of this lab, back in the lab area. Right? So you guys are rolling Hot Wheels cars down. And the question is like, what equation or equations could govern the motion of this car as it rolls down, right? Say some given angle. And some given gravity field, can't really change that either, right? So those are control. Okay. So you're trying to come up with some kind of way to describe, like as the car rolls down, exactly where is it going to be, at what time, and maybe how fast is it going, right? One nice thing about physics equations is that they have predictive power, right? You can predict the future. Like, how do you know, like, oh, there's going to be a solar eclipse like 17 years from now? And they know exactly. I don't know if that's true exactly. You guys get the idea, right? Right? Because physicists know like exactly the motions of things and can look like pan out to the future, right? So you'd be able to do something like that. Now, there's way too many variables juggling around here. See some kind of distance, some kind of time going on here. See the car's like changing speeds, has some mass. That's a lot of variables. So I have to split you guys into groups and have you guys do different experiments. I'm going to divide you guys up into 4 different groups. Do you guys see a card in the middle of the desk? You guys see a card? And it has a suit on it. Right? Each suit is going to correspond to one of these specific experiments. Okay. Okay. We've got 4 suits. We've got 6 groups here. So if you guys ever want to like trade lab members or team members or something, what I'm really looking for is that each one of these experiments is at least being done by someone. But some of you guys are going to be like the only ones with the particular set of variables that you guys are doing. So actually, you guys right here, you guys right here, right? These 2 tables. I'm really trusting you guys. You guys are going to get some really, really good data, right? Right. Maybe these groups over here, we're going to have some backups. But all right, so if you have the spades, I'm having you guys measure distance as a function of time, right? So you're going to roll the car different distances. Maybe go like, oh, let's try 50 centimeters. Let's try 90. Let's try 130, right? So different distances you like roll. And you say, like, how much time does it take? Start, stop, reset, right? So distances is a function of time. Now you'd be controlling for everything else. So the ramp angle, the mass of the car aren't going to change. Actually, the ramp angle is going to be constant for everyone, right? So you guys get there with the states? If you have the clubs, you're looking at the mass of the car as a function of time. So you guys remember yesterday I had some of those lab weights taped to the car, right? Now, you would only do that if you have the clubs, right? If you have the clubs, you're taping on lab weights to the car, right? And then you're going to fix the distance. So you might do like 200 centimeters every single time, but the mass of the car is changing, right? You say like, how much time does that take to do that? Right, you guys got that? Okay. If you have, now the hearts and the dimes, those two red suits, these are very similar setups at a glance. They're almost the same thing. So let's start with our hearts here. Hearts, you're looking at speed as a function of distance. So the car rolls down this incline, you're going to change the distance. So different distances you're using. Okay? And as it rolls through maybe a speed gate, you can use one of these speed gates. There's also that other equipment I was showing you guys yesterday. You can hook up to your phone with the Bluetooth. Right? Some students were trying that earlier too. Right? So what is the relationship between those two? And finally, if you have the diamonds, it's almost the same thing. You still have to change the distance. You're just not really keeping track of that. You're more keeping track of like how much rolling time, although that would also correspond to a different distance anyway, right? But you're really keeping track of like what's the speed as a function of how much time the car's been rolling for. Okay, if you have the diamonds, you guys got that? Okay. Any questions so far? Okay. Right, so you guys yesterday made this table. You guys got a big blank table, and I want to show you guys examples of things you can fill in some of these cells. Now we got, you guys see that, right? So you guys got your name, you guys got this title. You guys are going to measure an incline angle back there. Since I'm talking about angle, I'm going to get that up here real fast. Okay. So at a glance, I think you guys told me yesterday those inclines back there look about what, 5 or 10 degrees, you guys were saying, or maybe somewhere there. Right? So you guys know how to use this protractor. You say, okay, if I want the size of this wedge, what you did on your, say, like trigonometry lab, so you took this node up right on that corner, zeroed out one leg, and swoop the other leg, and it's all good. But when you guys get back to the lab area, it's like if you take this protractor and you put it like flush down on the lab table surface, problem is like, oh no, there's like this little space between like the bottom of the protractor and this node you want to get it at. So you can't quite put this node on this corner, right? Well, unless you put it at the side of the lab table or something, but it's like clunk, oh no. Right? But wait. All you have to do is put 2 points on the incline, maybe like the bottom side of the incline, take this node and slide it over. So it pops in place, and and then the incline, say like the bottom of the incline, will go right through the degree mark. You guys get that? Right. Now my picture here is like way steeper than the inclines back there, but it's the same idea, right? All right, so that's how you can get that. I'll walk back there and help you guys out. Now, what do you do with these columns? Well, it depends which suit you had, right? I've got 4 different kinds of experiments going on, right? Depends which card you have, right? So let me show you guys a prefabricated table, like as an example. Okay? If you're watching this video at home, let me put that up real close. Right, just watch the video at home. All right, there you go. Right. So everybody in here is in here. Right. So I might do something like this. I might do like under trial, you could just do this like 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. Or you could call it A, B, C, D, E, F, G, H, I. Right. It's just labeling like some trial. Remember, right? Do you guys see how across the tops of the columns, I have some variable and some unit? Like maybe you want to measure distance in centimeter. A lot of you guys are going to do that, or maybe you could do distance in meters. Do that too, right? Some of you guys are keeping track of that. Some of you guys are not. Right? Some of you guys might be controlling that. Maybe if you're doing velocity as a function of time, or no, scratch that. Right? Maybe if you're doing mass as a function of time, you want to make a note of what the distance is, but you'll just leave that the same all the way down. Right? That could be control, right? Or if you have a different suit, you might be changing that out. That could be your independent variable, possibly, right? Mass of the car in grams. You could go kilograms. You could go grams today. That might work. Right? Oh, look at this. Measure time. I got 1, 2, 3 boxes. Hey, could you guys do 3 and take an average? Right? Because that could help do what? Reduce random error. Right? Sometimes you're a little bit above. Sometimes you're a little bit. Sometimes, right? With stopwatch, it could take long intervals and short intervals, kind of average them out. Right? Okay. You know what I don't have a column for on this page is speed, right? And so many guys want to use the speed gate for, right? So you might have to do that, like speed, which could be in centimeters per second or meters per second, but it's always variable unit, variable unit, variable unit, right? You guys see that? Right. So when you guys are writing in your own table, you have some variable in unit, right? You might make a note of it, keep it controlled. You might have it as variable, right? Okay. Right. And finally, at the end here, I have a column that, well, what's this? Average time being squared, and this weird unit, it's like square seconds. Now, it's a very abstract idea. You may or may not want that specific column. Some of you guys need it, some of you guys don't. So some of you guys need another manipulated column, and that's related to these graphs here. Okay. So before you guys take off for the weekend, you'll have drawn these 6 graphs. Okay. Now, you and your teammates will be able to do either one or two of these. Since yesterday, I've gone ahead and also drawn in the suits to let you guys know, depending on what suit you have on your desk, what graphs you will be able to draw, right? So start with the clubs here. If you have clubs, you're changing out the masses, and you're saying like how much time does it take for cars at different masses for some set distance, right? Right. Oh, look at that, variable unit, variable unit. See how my axes are labeled with variables and units, right? So if someone's reading your graph, they say like, well, 200 what? Oh, 200 rings, right? Okay. Okay, if you have clubs, that's the only graph you'll be able to make before you walk out of class today. You might have a spare like 5 or 10 minutes of class today, possibly, right? So you can make a graph. If you have the spades, you're looking at distance as a function of time. I wonder what this is going to look like. It's going to be direct. It's going to be curved up like this, curved down like this. It's probably one of those. Okay? But I want you guys to also make another graph, or we will tomorrow anyway, as a class. Do distance versus time squared. Look, variable unit, right? Because I know what the outcome of this is going to be, and this is going to be very telling about the motion of that car down the incline. It'll be you guys will see when it comes together. Like, oh yeah, look at that. Right? And AP is going to want you to be able to do something like this too. Okay? If you have spades, you can possibly do both of those. Okay? If you have diamonds, the only one you'll be able to make velocity versus time. Okay? Velocity in centimeters per second, time in seconds. What that's going to look like. Okay? If you have hearts, you're looking at velocity as a function of rolling distance. Right? So be able to make some graph here. But I want you to have another manipulated column, another manipulated variable, which is going to be square all your speeds. That's if you have the hearts, go ahead and square your speeds, because this will also create a very interesting looking graph that is very telling about the motion of that car. Okay, you guys will see when it all comes together. I know all the answers because in this room many years. Right, you guys good so far? Good, everybody. Okay. And finally, since you guys are AP, while you guys are keeping your data, also do this 5-part write-up. You guys are going to do a number of these. I know this is your guys' very first lab, so as we go on through the year, you'll get more stuff. Okay, like I know what it is. AP will ask you an FRQ in May, a free response question in May, and it's going to follow this format exactly. Right? My students always do really well on that question because they had practice by then. And here you go. Here's the first one. So question: what's the relationship between blah and blah for the car rolling down the incline? Right. Depending on which suit you have on your desk, you know what to put in those blanks. Right. Maybe it's X versus T. Maybe it's V versus X. Right? Measuring tools. So what measuring tools are you using? Your procedure. So take 1 or 2 sentences to briefly describe the setup. Right? Have an incline, ramp it up at some angle, roll the car down, boom. Right? And then say what you use each measuring tool for. I use the triple beam balance to measure the mass of the car. I use the stopwatch to measure the time. I use the meter stick to measure the time. Okay, something like that. Right? Hey, maybe I took 3 times in an average to reduce experimental uncertainty. Bing, there's a point. Right? Analysis is basically graphs. You'll be able to do 1 or 2 of those at the end of the day. We're going to do the we're going to put all of them together, a big picture tomorrow's class. Right? Conclusion, some kind of equation. An equation could tell you the motion of the car down the incline. So you can figure out like mass and time and speed and distance. Maybe it's more than one equation possibly, right? Could tell you exactly what the car is going to do. All right, you guys good so far? All right, now I know that was a lot of pages. As you guys see different ones, maybe I'll flip different ones up here. I think I'll leave this one up here for a while. Right? Right, so go ahead, get all your data today and write up while you're at it. If you have 5 spare minutes at the end of class, maybe make the graph that you can make, and I'll be walking around helping you guys out. All right, that's a wrap on that recording.